Hi students, here we are going to do current electricity NCERT exercise question number 9. Let us start. Here they are asking to find determine the current in each and every branch of the network shown in the figure. I think it is similar to it looks like a Wheatstone bridge. Let us check whether it is balanced Wheatstone bridge or not. This is P, this is Q, this is R, this is S. P by Q equal to R by S or not, I am going to check. P is a 10, Q is a 5. R is 5, this is 10. 10 by 5 is not equal to 5 by 10. This is not a balanced Wheatstone bridge. Then we will go for the alternate technique. Use the Kirchhoff rules, like a current rule, a junction rule, and potential rule, loop law. Let me draw the diagram. Here 10 ohm. This is 5 ohm. Again this is 5 ohm. This is 10 ohm. Here it is 5 ohm again. 5 ohm. It is connected to 10 ohm followed by a battery 10 volt. They gave the junction names like A, B, C, D. Also I'll tell this battery name E. Right, first we'll go for the current division. How the currents will divide. From this, let it be I current drawn from the battery positive terminal till here the current I will comes. Why? Because no junction at this point. But at this point A there is a junction, current is going to divide. I will tell in this let it be I1. The remaining current will be I minus I1 in this. You know the division of currents. I total, I1 went in the A to B. The remaining current I minus I1 will go in the other branch A to D. Now till here B, I1 will go, then here it is divides, let it be Ig will flow in this. It is purely our assumptions. Ig will leaving the branch B, then how much in this B to C? B to D Ig, total I1 entering actually B, the remaining will go I1 minus Ig in the B to C. Because total I1, Ig went in the B to D, the remaining will be I1 minus Ig. Now coming to the junction D. Till here Ig enters. Till here Ig enters. And I minus I1 also is going to enter here. And what about the leaving? Leaving current should be equal to sum of entering currents. I minus I1 plus Ig. This is entering current. Then coming to the junction C. At junction C, entering currents I1 minus Ig plus I minus I1 plus Ig also entering. This is entering. This I minus I1 plus Ig entering. I1 minus Ig entering junction C. At junction C. Then that will be equal to leaving. Leaving let it be Y. What is the Y here? Minus Ig plus Ig. Minus I1 plus I1. Then Y equal to I. Then same current I will reach the negative terminal. This is the current division. Once the current division is done, the remaining part is very simple. Now I'll take the loop. Loop A, B, D, A. Loop A, B, D, A. Like this. A to B you are moving. When you are moving A to B, your loop direction and current direction both are same. And both are same, then potential drop minus I into R. I is I1, resistance is 10, minus 10 I1. And B to D again, current direction and your loop direction same. Again resistance into current, minus 5 IC. Then coming to D to A, but D to A, your direction, loop direction and current direction opposite to each other, then plus IR. R is 5, I is I minus I1 equal to 0. Simplify this one. Minus 10 I1 minus 5 IG plus 5I minus 5I1 equal to 0, which is 10 I1 minus 5I1 minus 15 I1 plus 5I minus 5IZ. I'll do one thing, students. Here I'll take 5 common, minus 5 common. When I take minus 5 common, 3I1 minus I plus IZ equal to 0. This is equation number 1. From the loop A, B, D, A, this is the first equation. Now coming to the next. I will draw the currents here. I current till here, same current I. Now in this I1 is entering, in this I minus I1, here it is IG, here it is I1 minus IZ, in this I minus I1 plus IG, that's it. Then here how much current out means same current I. In previous page I derived the same thing. Now coming to the loop B, D, C, B. Loop B, D, C, B. The loop how it is like this. I am going in this manner. B to D you are going, when you are going B to D, your current direction, IZ direction and your loop direction same, then minus 5 into IZ. B to D is over, then D to C. D to C again your loop direction, current direction same, minus resistance into current, I minus I1 plus IZ. Then D to C over, C to B. C to B, your current direction and your loop direction both are opposite to each other. You are going from C to B, but current is going from B to C. Then plus 5 into I1 minus IZ equal to 0. Next line. Minus 5IZ minus 10I plus 10I1 minus 10IZ plus 5I1 plus, not plus, minus 5IZ equal to 0. Then how many I1 terms are there? 15 I1. How many I terms are there? Minus 10I. Only minus 10I is there. Minus 10I. And how many IG terms? Minus 5IG, minus 5IG, minus 10IG, minus 10, minus 20IG equal to 0. Then I will take 5 common in this. 3I1 minus 2I minus 4IZ equal to 0. Equation number 2. These two equations are enough to solve I1, I, IZ. 3 unknown variables are there, I1, I, IZ. 3 unknown variables are there. You need 3 equations. 2 equations won't sufficient. Then you take one more loop. That loop I will consider like this. Loop A, B, C, E, A, where E is the battery. A, B, C, E, A. The loop direction I'll show you. Students, carefully you see. A to B you are going like this, then B to C you are going like this, C to E, E to A like this. A to B, B to C, A to B, B to C, C to E to A, like this, right? First coming from A to B. When you are moving from A to B, what is your loop direction? Current direction, same direction, minus 10 into I1. B to C, again same direction, your loop and current, minus 5 into I1 minus Ig. This 5 into I1 minus Ig, same direction, that's why. Next, coming to C to E. C to E, no resistance, but at E1, negative to positive you are moving. Whenever you are moving negative to positive of the battery, you have to write plus. Why? Because it is a gain. Gain, I told the sign convention plus. And again here one resistor is there. That resistor current direction and your loop direction same. You are going, then minus 10i. Minus 10i, loop completed 0. Minus 10i1 minus 5i1 plus 5iz plus 10 minus 10i equal to 0. How many I1 terms are there? 2. Minus 15i1. Only one Ig term plus 5Ig and one 10i is there, plus 10 equal to 0. I will take one. I will do one thing. Minus 5 again I will take common. Minus 5 you take common, 3i1 minus Ig plus 2i minus 2 equal to 0. I will write it as 3i1 minus Ig plus 2i equal to equation equal to 2, that is equation number 3. Now you have 3 equations, 3 unknown variables. We can solve it. 3i1 minus Ig plus 2i equal to 2. Take the first equation. 3i1 minus I plus I is equal to 0. 3i1 minus I plus Iz equal to 0. Equation 1. What is equation 2? Equation 2 is 3i1 minus 2i. 3i1 minus 2i minus 4iz equal to 0. Equation number 2. Third equation. What is third equation? 3i1 plus 2i minus 3i1 plus 2i minus Iz equal to 2. Equation number 3. 3i1 plus 2i minus Iz equal to 2. Okay, right. Now solve 1 and 3. Solve 1 and 3. I am going to eliminate Ig. Because here plus Ig is there, here minus Ig is there. Then equation 1 plus equation 3. 3i1 minus I plus Iz equal to 0. Next 3i1 plus 2i minus Iz equal to 0. I am going to add, these two terms gets cancelled. 6i1 plus I equal to 0. 6i1 plus I equal to 0. Equation 3, sorry, here 2 is there, sorry students. 0 plus 2, 2. I'll say this is equation number 4. Okay, 1 and 3 over. Now I'll solve 1 and 2. Solve 1 and 2 to eliminate again Iz. 1 and 3 over, 1 and 2 over. If you want, you can calculate 2 and 3 also, no problem. In such a manner, you eliminate Iz. Here Iz is there, here 4i minus 4Ig is there. Then equation 1 into 4. Equation 1 into 4, which is 12i1 minus 4i plus 4Iz equal to 0. 3i1 minus 2i minus 4ig equal to 0. Then plus 4ig minus 4ig cancel. 12 plus 3, 15i1 minus 6i equal to 0. Then 15i1 equal to 6i. Then I equal to, or else I'll divide with the 5 table. 5 3s 5 2s are, sorry, 3 5s 3 2s are. 5i1 equal to 2i. I equal to 5i1 by 2. 5i1 equal to 2i. I equal to 5i1 by 2. You substitute this 5i1 by 2 in the equation 5. What is equation 5? 6i1 plus I is 5i1 by 2 equal to 2. 6 to the 12, 12 plus 5, 17i1 by 2 equal to 2. I1 equal to 4 by 17 ampere. This is I1. I1 is the current in the branch AB. 1 is over. Then you calculate I also. What is equation 5? From equation 5, what is equation 5, students? I equal to 5i1 by 2. I equal to 5i1 by 2, which is 5 by 2 into I1. I1 is just now you got 4 by 17. 2 to the, which is 10 by 17. I equal to 10 by 17 ampere. Then Ig also you try to calculate by solving. Where is Ig? I'll use equation 1. From equation 1, 3i1 minus I plus Ig equal to 0. 3i1 is 4 by 17 minus 10 by 17 plus Ig equal to 0. 3 4s are 12 by 17 minus 10 by 17 equal to minus Ig, which is 12 minus 10. 2 by 17 is minus Ig, but Ig equal to minus 2 by 17. Negative currents won't exist. Negative means here your direction is wrong. You consider like this means actual will be upward. Students, is it clear? I1 equal to 4 by 17, I equal to 10 by 17, then Ig equal to minus 2 by 17. Minus 2 by 17. Now, they are asking to find what are the currents. What are the currents? In AB is I1, in BD is, note it down this one, AB is I1, BD is I minus I1, in branch AB, current is I1, which is 4 by 17, but in the branch A to D it is I minus I1. I minus I1 means I is 10 by 17, I1 is 4 by 17, which is 6 by 17 ampere. You need to write units also. Then what is the branch A, B or BD? BD means middle one. In BD it is Ig, which is minus 2 by 17. AB over, AD over, BD over, then A to C. A to C you got I1 minus Ig. I1 minus Ig. I1 is 4 by 17 minus Ig. Ig is minus 2 by 17, which is 6 by 17 ampere. Then AB over AC over AD over then AB over BC over AD over DC. DC it is I minus I1 plus Ig. I is 10 by 17 minus 4 by 17. Ig is minus 2 by 17. 10 minus 6, which is 4 by 17 ampere. D to C also over 4 by 17 ampere. And total current 10 by 17. This is your answer.